My dear students, Assalamu alaikum. This is the lecture 18 of database. So in the last two lectures, in lecture number 16 and lecture number 17, we have learned some techniques of the normalization, why the normalization is needed, and what are the forms of the normalization, and what are the triggering or what are the things we should need to make a table normal, and what are the steps. So in the last slide we have so far learned that each of the normal form having some rules, having some criteria, having some regulation. So today we'll go for the first normal form. So first normal form, it is in short said 1NF. So in the first normal form, that is having some parameters, having some rules and some norms. So what are the rules and norms? A relation is in first normal form if it is satisfied the following conditions. So a relation means a table. It is in first normal form if it is satisfied the following condition. What are the conditions? Number one, it should only have the single or atomic value attributes columns. So what does that mean? That is, in every attribute or in a column, it should contain a single value. There should not be multiple values for each of the tuple in a attribute or in a column. So there should be a single value for each of the tuple in each column. So that is the rule number one. Rule number two, value stored in a column should be of the same domain. So each of the column should have the same type of values. So if you inserting a phone number in a column, so you cannot enter a email address, so data can be violated. So in each column you have to put the same type of data. Number three, all the columns in a table should have unique names. So names of the attributes should be unique of each of the table. Whenever you are using SQL, you might have tried to create a table with the same name which is existing. That should not be created. So if you want to create with a table with same names, so it cannot be created in the SQL, because the rules is you should have unique names for each of the columns or attributes. Number four, and the order in which data is stored, it doesn't matter. So you can insert the data in any fashion, for like roll number 10 can be inserted at first, roll number 1 can be inserted at last, so it doesn't have any matter. So these are the four rules you need to be understand, you need to be memorized. That is, all the values, all the inserted in an attribute, it should be atomic, it should be single. Number two, the columns, the values you are entering in a column should be the same type, same domain. Number three, the names of the attributes should be unique, and the value you inserting in the rows, it doesn't matter, it doesn't need to be sorted. So if we go for an example, that is a course student, in the course student table we have so far seen here the three columns: student ID, student name, and course taken. So in the student ID, there are some IDs in the name and the course taken. Here you see the roll number 1701040001 is a student, Adam Hurt. He is taking three courses: information system design, database, and telecommunication. In the other examples, or other students also take one or two courses, each of them. So if we now, what is the thing we need to check? So whenever we starting to check this table is normal, we starting from the rules of first normal form. So from the first normal form there are four rules. The first rule is each of the column, each of the attribute should have atomic values. So atomic values means single value. Here you see the course taken field, the course taken attribute having more values. A student is taking 3 courses, but 3 courses is inserted in a single tuple. So that's why how it is been creating a problem whenever you are choosing your analytics with that how many courses this student taken. So if it is inserted in a same tuple, it might be show one row, return one row, right? So if the student is taking 3 courses, it need to be returned 3 rows. So roll number for the roll number 1, Adam Hurd, it whenever you are creating some SQL, it shows how many courses taken. It is just reflecting one row return. Here 3 courses. So it should not be, because there are 3 courses here. So it is violating the rules. Rule number 1, it is violated. Rule number 2 is whenever the data are putting in the columns, it should be the same domain. Here all the data are putting in the same domain, all the data types are same, so that is maintaining the rule. Number 3, all the column names should be unique. Here student ID name and course taken all are unique names for the attributes, so it also maintains the rule. Number 4, data can be inserted in any fashion, so it also maintains the rule. But among the 4 rule number 1 was violated. Rule number 1 as violated, so it is not following the norms of the first normal form. So this table is not in the first normal form, so we have to make it in the first normal form. So how we can make it? So if we want to make a first normal form, so as the table course student was previously created, so we want to modify it, we have to renew it. So what do we have to make? We have to rename a table, we have to create another table, and also need to give a new name, because we cannot create 2 tables on a same name. So the thing is that we should create a table like this, that is the student ID, name and course taken, columns names are same, where we inserted the data with each of the tuple. Here you say no data is changed, but roll number 1 Adam Hart is taking 3 courses. 3 courses of data are inserted in the 3 tuples. Roll number 2 was having 2 courses, database and operating system. These 2 data are inserted in the 2 tuples. So when you are now running a query that how many courses does roll number 1 Adam Hart taken for this semester, there will be 3 tuple returned, that is information system design, database and telecommunication. So where the data is matching with 001 and there will be 3 tuples returned, so 3 courses he has taken for this semester. So this is how the normalization can be done for that table. And we also check the next rules, that is all the data are from the same domain, so it is maintaining the rule. All the data are all the columns names are unique, that is also maintaining the rule. And the final thing is the data can be inserted in any fashion, so it is also maintaining the rule. So there are 4 rules, all the rules are maintaining by this table. So we can say that this table course student new table is in first normal form. So if we look for another example, that is book ID author, there is another table named booked. So in this table you show that all the values are inserted here is atomic, but the column names are not unique. 3 columns having the same name, author. A book might have different authors. A book might have 3 authors, 4 authors, or it might have 10 authors. I have seen, suppose like if you have a book like Encyclopedia Britannia, so there might be 20 authors, there might be different chapters, there might be different things. If you are looking for some history book, that is, you want to learn the history from the Mughal Empire, you want to learn the Turkish Empire. So here each of the individual chapter is written by an author. So there will be 25 or 26 authors for the same book. So how many columns will be you want to create it for this? 25? Is 25 is enough if there are more than 25 authors? So what you will have to do here? So in this type of problem, we have to check again the rules. Here the first rule is maintain, that is all the columns having the unique or atomic value, but rule number 2 is violated, that all the columns name are should not unique here. Number 3 is all the values are in this from the same domain. Okay, so it is maintained and data can be inserted in any way. It is always maintained. So how can we convert this table to a normal form? So we can do it for like that. If we just change the thing, first of all we have to create a new table. It is book new. So we can change the author attribute. So that is author 1, author 2 and author 3. It is an easy solution first of all. But the problem is if there is more than 3 author, what you have to do? You will create a new attribute. Okay, fine. Then if you have 25 authors, so what will you do? Create 25 columns, but most of the book doesn't have 25 authors. So that all the fields will be null when you have creating 25 authors, or author 1, 2, 3, 4, 5 along 25. So all the columns are having no data, they have the null data, but you have created for a single book which having 25 authors. So database space will be wasted. So we cannot do it. So we make some easy policy for it. We create another table like book new 01, because it is all we have already created book underscore new, so we cannot create another table book underscore new. So we give a name book underscore new 01. The name is totally upon you. You can give any name, A, B, C, D, whatever you like. So the book ID is inserting here the 2 columns only, book ID and author. So by a book ID there can be a lot of authors. So you can ask me that, sir, that book ID is a primary key. How can you inserting a primary key with some different data? Yes, a primary key is a single one, but it having contain a different type of data. As you were a student, you can give 8 semester fees. For the 8 different semester, that will be 8 slip will be generated, 8 entities will be generated, but your ID cannot be changed. So for a single value, I can insert again and again for a different type of data. You can go for a canteen. So if you are going to a canteen, a money receipt will be generated. So the money receipt will be generated along your student ID. The student ID is using in a day for several times, in a month for 1,000 times. So that should not be the problem, because each of the time variant is different. If each of the time the item can be different, if of each of the time the money can be different, so that is not the problem. So this is how you can manage the data of the first normal form. So if we check again this table is okay or not. So here the data is atomic, here the column names are unique, here the data are inserted from the same domain, and data insertion in any way, that is not the problem. So this book new table is maintaining the first normal form rules. So if we go to the second normal form, what is saying? A relation is in second normal form if it is satisfying the following condition. What are the condition? it should be in the first normal form. So a table, if it is going for the second normal form, it should have to be first normal form at first. So maintaining the 4 rules of the first normal form, then it will go to the second normal form. If it is fails to make the first normal form, then you have to make it first in the first normal form, then we'll apply the rules for the second normal form. So what another rules is, and it should not have partial dependency. So what is a partial dependency? Whenever there is composite attributes in the determinant side, if some attribute is deleted, the whole relation is not impacted. It was said in the partial dependency. So in the second normal form, you have to understand it should not have partial dependencies. So in the table, there should not have any chance to create a partial dependency. So it should be full functional dependent. So all non-key attributes are fully functional dependent on its primary key. So in a table, there might have different type of datas, different type of columns, but all the columns, all the attributes should be dependent on its primary key. So primary key will be the determinant and the other attributes will be the object of determinants. So the object of determinants will be always dependent up on the determinant who is taking the decision. So the object of determinants, the other attributes, should be controlled by the primary key. That is the rule here. So if we're looking for this table, it's a customer table. In this customer table, we are saying here the 5 columns. Each of the column, firstly we have to check this table is in the first normal form or not. Here 5 columns, each of the column having the atomic values. Here each of the column having the same domain type of values. Each of the column having the unique names, and data inserted is not the problem. So this table is a first normal form. But here in the second normal form, as it is a first normal form, now we'll check the rules of the second normal form. In the second normal form, it is said that non-key attributes are fully functional dependent on its primary key. So there should be no partial dependency. So non-key attributes here show that customer name, address, status, these are the non-key attributes. Here key attributes is customer nong and account nong. These two are primary keys. So here you see that on the customer nong, name is dependent. On the account nong, it might be dependent on the address or something like that, or status. So all the non-key attributes are not dependent on its primary key, because account nong having some different type of values and customer nong having some different type of values. So here 2 primary keys, one is customer nong, another is account nong. So name, address, status of a person is dependent on the customer nong, but here key is 2. So name, address and status is not dependent on the account nong. If the scenario is like that, so it is violated the rules of the second normal form. So if we decompose this table here like that, this is the customer, suppose like the customer table. So customer nong is stems to customer name, address and status, and account nong is stems to name, address and status. So customer nong or we can say that customer nong and account nong tends to name, address and status. So in the left hand side, which is determinant, so customer nong is the determinant, so name, address, status is dependent on the customer nong. If we say that the account nong is the determinant, so name, address, status is dependent on the account nong. Or if we say that customer nong and account nong both are determinant, so name, address and status are dependent on the customer nong and account nong. Here, if we delete one attribute like customer nong, if we delete, okay, so if we delete one attribute like customer nong, so the rules will be violated. What is the rule? The partial, there should be no partial functional dependency. In the partial functional dependency, what we have read, if we delete some attribute from the determinant side, no impaction will be happen in the functional dependencies. But here we see that customer nong, if we delete the customer nong, some impact will have, because customer nong is fully controlling the name, address and status. If we delete the account nong, so the same thing will be happen again. So what will be the solution then? So we have to make here two tables. Either we will make the customer nong with name, address and status, or the customer account nong with name, address and status. Here we are creating the customer info table. So in the customer info table, we are creating customer nong, customer name and customer address and customer status. So customer name, customer address and customer status, all the three attributes are dependent on the customer nong. So no rules are violated. So all the non-key attributes are fully functional dependent on its primary key. Here non-key attributes are name, address and status. These three attributes are fully functionally dependent on its primary key, customer nong. And another table is account customer. In the account customer, it is already having two keys. There is no non-key attributes. So only two keys, and these two keys are primary keys. So here already it is maintaining the second normal form, so nothing to be checked here. So this is how we can convert the second normal form tables. So that is for the all for today. Thank you, and stay safe, stay at home, don't go outside if it is not necessary. Fi amanillah. Thank you.